Guys, this is Ms. Miner, and today we're going to be doing lesson 3C. And our goal for today is to be able to understand that a linear equation and its graph are functions. And we're going to use real world problems or story problems, right? An example from something you might see in the real world in order to be able to accomplish our goal for today. But let's pause really quickly and let's just talk about this word right here, linear. What is a linear equation? Well, this equation actually tells us what it is in its name. See this word right here? When I graph a linear equation, it makes a straight line on my graph. A linear equation is a straight line. So we are going to be using an equation today that when I graph it, it makes a straight line. And we learned in our functions lesson that equations that give us straight line graphs are functions. We said all straight lines on a graph are functions except for vertical lines. So that was what we had talked about during our last lesson about functions. And so today we're going to be graphing some straight lines and kind of starting to recognize how functions work. So last time we were talking about functions, we said that I wanted to put in an input. So I'm going to use our homework machine that we had from our last lesson and kind of use it to illustrate how we collect data from an equation. Okay, I'm going to input something, right? I want to put something into an equation and then it's going to tell me its output. And today we're going to need to collect some data from our equations. And so we're going to be working with some inputs and some outputs. And remember, our input was our x variable and our output was our y variable. So let's just try and collect some data. And we use these XY tables in order to collect data. Let's collect some data on a linear equation. So I'm going to give you an equation, 2x plus 1. And I'm going to say, okay, if I put in, right, if my x variable, if my input were a 0, right, if x were a 0, then what would my output for that be? Right? If I put a 0 in for x, so I substitute a 0 in place of x, then what would I have as an output, right? I would put in a 0 here. Instead of an x, I'm going to put in a 0 right there. So now I have 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1. So my output would be a 1. Well, what if I had a different input, right? What if my input for x was a 1? What if I put a 1 into this equation? What would I get out? What would my output be? So now instead of a 0, I'm putting in a 1 for x, right? 2 times 1 would be 2, plus 1 would be 3. So now my output is a 3, right? What if I put in, this time I'm going to put in a 2 for x. If I put in a 2 for x, and this is how we collect data. We put in a number into our function machine. We get out a number in our function machine. And our equation looks like or performs like a machine, right? I put a number in, 2 times 2. In this case now, x is 2. 2 times 2 would be 4, plus 1 is 5. So I would get out a 5. And so this is how we collect data from an equation. We do it by putting in an amount, and then it gives us our output. And this is a function. You can see that anytime I put in a 0, I get a 1 out. What if I put in another 0? Let's try again. What if I put a 0 back into this again? Will I get the same thing again, right? So if I put a 0 back in here, Now x is a 0. 2 times 0 plus 1 is 1. So you can see this function is working properly because the first time I put a 0 and I got a 1 out. The second time I put a 0 and I got a 1 out. So here's my function machine, right? My function is giving me only one y value for each x value. All right, so that's kind of how we're going to do this today. We're going to get some data from our equations. We're going to collect it up on a XY chart, and we're just going to do it by using the input and the output. We're going to put in a number into our function, and we're going to get calculated and get an output. And then we're going to use that to help us graph. So let's figure out where our equation is going to come from. Oh, I want to get a blank page here. Let's get a blank page, and let's there's our function again. Okay, let's split screen this. All right, so remember when we were doing story problems before, we had a 2-variable equation that we were using. Y equals blank x plus blank. And this was kind of our setup in order to be able to write an equation from our story problems. And we said that in order to know what number was going to go in this blank, right? This was going to be a number, and this was going to be a number that we filled in from our story problem. And in order to know, we were going to look for specific words. We were going to look for per, or every, or each. We needed to find the unit rate. And so those were going to be some words that we were looking for. Over here, we were going to look for a fee or a starting value, an initial amount, something like that. And that's how we were going to know what's going to go in that space. Okay, so the first thing that we want to do here then is we want to get a story problem. Here's our story problem. We're going to write an equation from this story problem. Let me move some of these things out of the way. All right, we're going to write a story problem. And the way that I do this is I start by writing my equation first. I get my equation set up, and then I know what my equation is going to look like in order for me to collect the data. So I start right here at this place where it says write your equation, and I set it up. This says y equals, and I write out blank x plus blank, and I'm going to fill in those blanks with a number from my story problem. And I'm going to use this over here in order to be able to write my equation, right? I'm going to use my notes. So this right here is very important. You should make sure you have it written in your notes because you're going to want to know what to look for in your story problem in order to be able to set up your equation. So make sure you have this all written down in your notes. Okay, so I'm going to look for per, and I'm going to look for some kind of unit rate, and then I'm going to look for a starting amount or an initial value, something I have to pay up front. This says the rental rate at Rent-A-Wreck is $30 per day plus 25 cents per mile. And here's the thing, right? In the real world, we don't always have things work out the way that we want them to, right? I'm looking for the word per, and in this situation, I see the word per twice. So the next thing that I do is I read the rest of the directions, and I try and figure out what is it exactly that I'm looking to find out? What is it asking me to find out, right? And this says, write and graph the equation to represent total cost. Oh, I want that to be a highlighter here. Sorry. Total cost to rent the car, X number of miles. X is my number of miles. I want to know. So this over here says X is miles. And remember, my X is my per what? Per mile. So I want to look for this number to be per mile. Up here, I have one that's per day and one that's per mile. So which number do I want to put into my box right here? I want to put in the one that is per mile because it tells me that's what my X is right here. So I'm going to put the 25 in here for X because I want the one that makes X be miles. And the 25 cents, that'll be 0.25. The 25 cents is the one that's per mile. Now, something else really cool is I've already defined what my X variable is. It's miles. So above it, I've already determined what miles is. Now I just have to decide, let's fill in that means this last blank is $30. I have to pay $30 up front. That's my initial amount that I have to pay before I can drive the rental, right? Some miles. So that's my upfront cost. So that's going to go in my second blank. So we can fill that in now. Now I know what my equation is. I'm just going to erase that. Oh, that's very big. This was miles. Okay. Now I just have to define what my Y variable is. I want to know what it is. And guess what? It's already told me because I'm looking for, remember, Y is my total. Always my total, and so this is already told me I want to know what total cost is. So X is miles, Y is total cost. The very next thing that I'm going to do after I've defined my variables and written my equation is I'm going to go to my graph because I want to label my graph. Remember when we said we needed to always have a label on a graph? So when we were reading our graphs before, in order to be able to read our graph, we had to know what our graph was telling us about. Well, we already have defined what our X and Y are. Where is my X on a graph? My X is my X axis. So this is going to be miles on my X axis. Milex. X is going to be miles. And my Y-axis then is going to be total cost. So I get my graph labeled so I know what I'm graphing. And then I want to take my equation, and I'm going to write it over here so we have some space to do some calculating, some inputting, and some outputting. Okay? Remember, I want to take my equation, why is this not changing colors here? It says green, but now I want to change it to black. Okay, I think I got it. No. Okay, well, there we go. Y equals, right, 0.25 X plus 30. There's my equation. Now I've got some space to do some calculating. Remember, X is where my input goes, and then I'm going to calculate this equation with my input in there, and I'm going to get my output over here. I'm going to get an input that I'm going to list here, and I'm going to get an output over here. And this is going to be my miles, and this is going to be my cost. So we can go ahead and label all of our things that are going to be X's and Y's now, right? They all correspond to each other. My data corresponds to my graph, which corresponds to my equation. The next thing that I wanted to do, remember on a graph, there were two things that we put in our notes that we needed to have. We needed to have a label, and we needed to have a scale. So I want to create a scale on here. And I'm probably just going to go by ones here, right? This starts out at 0. My cost is 0. And then I'm probably just going to say this is going to be a 1, 2, 3, 4, and so on and so forth. But in order to be able to determine really what I want my scale to be, I need to know what my data looks like. And so I'm going to pick some data points, and you can choose whatever data points you want to put in. You can put in a 0, you can put in a 1, you can put in a 2. I'm going to look up here at my equation, and I can see that I'm going by 25-cent increments. And so I'm going to definitely choose 0 because 0 is always the easiest to calculate with. And then I'm going to choose 4 as my next data point that I want to graph, because I know that there are 4 quarters in one whole dollar, and I want this to come out as a whole number. So I'm going to use the data point of 4, but you could choose whatever you wanted. I just don't want to work with decimal numbers. So I'm going to choose numbers that I know are multiples of 4 so that I get whole number dollars. It'll be a lot easier for me to graph. Okay, so I'm going to choose 4, and then I could choose any other multiple of 4 that I wanted, but I'm going to choose 20 because that'll give me a really good data point out, and I want to make sure that I get my graphed pretty accurately. So I like to kind of choose a couple that are within a range, and then I like to choose one that's a little bit farther out. But we don't have to. We could choose 8, or we could choose 10, or we could choose whatever number we wanted. We're just saying these are going to be my input numbers. All right, so what do I do next? Well, I go to my equation and I actually put the input into the equation. So my first number that I chose as an input was 0. So I'm going to take a 0, I'm going to put it into my equation, and I'm going to get an output, right? So my equation is y equals 0.25 times 0 plus 30. Then I calculate it, and you can use your calculator to do it. 25 times 0 is 0, plus 30 is 30. So my output now is 30, right? If I have 0 as my x value, my total cost is $30. And this should be kind of, this should make sense, right? If I don't drive any miles, then I only have to pay the $30 for the rental. What if I drove for 4 miles? So what if my input now was 4? What will my output be, right? So I'm putting it in here. Y equals 0.25 times 4 plus 30. And 25 times 4 is $1 plus 30 is going to be y is equal to $31. So I'm getting some data on this equation. The last thing that I'm going to do is the 20. And so y is equal to 0.25 times 20 plus 30. 25 cents times 20 is $5. So 25 times 20 is $5 plus the 30 is going to be $35 is my total cost if I go 25 miles. If I go 20 miles, right? Okay, so now I need to set my scale up so that it fits my data. I want to get my x value to go from 0 up to 20. So I'm probably going to see, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 lines. So if I go 2, 4, let's go by twos. Let's go by twos. So this would be, this next one would be 2. I always kind of try and figure out, this would be 4. This would be 6. Let's make this really thin. Let's make this really thin. Come on, line. There we go. Let's make this be nice and thin. Okay. This is going to work. That's going to be 0. What? Yeah. Line thickness. Right there. That's what I want. This was supposed to be. That's going to be 2. That's going to be 4. There we go. That's what I want. This will be, yeah. Sorry, I have to learn how to use my board here. That'll be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I didn't put the 16 in there because it was getting real squishy, so I skipped over that one. But it's in there. I just didn't write the 16. Okay, so I'm going to get up to 20. Then this would be 24. And this would be 28. We're not going to get up that high, though. Okay, now my y variable, I think I'm going to go by 5s. I think 5s will get there. That means this would be 10. This would be 20. This would be 30. This would be 40. This would be 50. Okay, and so on and so forth, right? Okay, so once I've created my scale that fits my data, that kind of gets me there, I am going to graph this. So I've got to have some points, right? So my ordered pairs, remember, I just take my x value and my y value, and there is the point that I'm going to graph. When x is 0, y was 30, and I put a point right on my graph. When x was 4, y was 31. So I can go up to 4, and then I have to estimate a little bit because I can't actually get 31 in there, right? Because we went up to 35. So I kind of just give it an estimate. And then when x was 20, y was 35. And so now I can go up here and I can get all the way up to 35. And then I can draw a line. I want to get a line this time. And you're going to use your ruler to draw a nice straight line on your graph across your points in order to see, that one should probably move down just a little bit there, where your line goes. That one. Move it down. Yeah, because 31 would be, there we go. Okay. So now we can see exactly where our line is going. And we have taken a equation, a function, we've created a table of values, and we've graphed it. Now, what if I wanted to make a prediction? What if I wanted to predict the cost for something way in the future, right? A way big number of miles, 250. Well, I can actually use this function now that I know where my data is going. I can use this function to help me predict what my cost would be for any number of miles that I've driven, right? Because I know that all I have to do is make an adjustment in what my input is, and I can use this function to make a prediction for a future number of miles. What would my cost be if I drove 250 miles? Put it in as your input into your function and get out your prediction. We can see exactly where this is going to go in the future. If I want to make a prediction for the cost for 250 miles, my equation would be 0.25 times 250 plus 30. And I can just use my calculator to do my calculating for me. 0.25 times 250 plus 30. And I'm going to get $92.50. So my cost for driving 250 miles would be $92.50. And that's how we can use functions in the real world. Once we figure out, this data has a pattern that's kind of a straight line, right? And I know linear equations are functions. And so I can use this function as a good prediction for cost in a future number of miles, or if I'm driving multiple numbers of miles. And all I have to know is that a function works by inputting and outputting. Okay. So let's do this again. We are going to I'm going to go back to my full screen. We're going to do another one that's just like this. Okay. Let me see, not that one. I want to make this big. There we go. Okay, not quite that big. Well, maybe that big. All right. So the first thing that I always want to do is set up my equation. Y equals blank x plus blank, right? And I'm reading my scenario to figure it out. It says, at the fair, Bob draws caricatures. He pays the fair $30 for a space to set up, and he makes $2 for each drawing he sells. So there's a couple of things happening here, right? I want to know, first of all, let's decide, right, what my unit rate is. What is my per number that I'm going to put in here? Well, we said earlier that it would be okay for me to look for the word each, and that meant the same thing as per. So $2 is going to go here, and it's each drawing. So remember, my X is the per what? Whatever it is per, this is $2 per drawing. So whatever it is per, remember that's what my X is. Now, what is it that I'm looking for? What's my total here? What does my Y represent then? Total what? Well, I want to know total money, right? Total money that I'm making at the fair. Now, there's an important part of this. It says that first I have to pay up front. I have to pay $30. So if I'm looking for total money that I made at the fair and I had to pay some money up front, I need to make this be a negative $30 or make this be a minus $30 up front. I'm already in the hole before I start selling my drawings, right? So I'm going to have to make up my $30 to start with in order to earn money at the fair. So now I can kind of make this smaller. So now we have our equation. Total equals 2x minus 30. Let's get some data. Actually, let's label our graph first. I always like to know what it is I'm graphing. And my x-axis over here is going to be the number of drawings that I sell. And my y-axis over here is going to be, excuse me about that, is the total money that I've earned. Money earned or money made. Okay. Now, let's get some data. I'm going to do drawings and money earned. So if I don't sell any drawings, right? Remember, X is drawings and Y is money earned. Okay. Well, what I want to do in order to be able to do this, remember, this is my function machine right here. If I put a 0 in here for X, then how much money will I earn if I don't? Well, I'm going to be minus 30 in the hole, because if I don't sell any drawings, I had to pay $30 to rent the booth. So I'm going to end up $30 in the hole, right? What if I sell one drawing? Then I would be $28 in the hole. So now I'm going to kind of choose, right? Sorry, I want to put this back up there. Okay. What if I did 5 drawings? Is 5 enough to get me out of the hole? Well, I'm going to input, right? And I'm going to get a total out. So my input now is a 5. 2 times 5 would be 10. And 10 minus 30 is still negative 20. So that wasn't enough. What if I did 10 drawings? Was that enough to get me out of the hole? So up here, I'm going to erase, hopefully. Oh boy, that's what I didn't want to do. I'm going to put in 10, right? So I'm kind of just guessing some data points that might get me, where I'm actually earning money now. So 2x plus 2 times 10 would be 20. Oh man, that's not going to be enough, right? I'm going to have to sell more than 20 drawings. So let's try and get us up into the positive earnings. Let's pick 25. Let's pick 25. Let's pick 30 drawings. What if I sold, that was x minus 30, right? What if I sold 30? 30 times 2 would be, so my x was 30. 30 times 2 would be 60 minus 30. I'd have $30. Oh, this is looking even better. So let's go ahead and graph some of this. Where is 0 on my graph now, right? Remember, y is positive up here. Y is negative down here. X is positive over here. So where is my 0? Well, here's my 0. Anywhere where my x and y meet up, that's 0, 0. That's my origin, right? So we said at 0 drawings, how much money had I made? Let's go by tens here. Let's see if that's going to get us there. Let's go by fives actually in both directions. That'll help. That'll be a good scale here. Let's do by fives. So this was 0. This will be minus 5. This will be minus 10, minus 15, minus 20, minus 25, minus 30, minus 35. Up here, this will be 5, 10. Let's go up to 20 so that we can, this will be 30, 40. Okay. And over here, let's do 5s along here as well. So let's switch over to green so that we can have, that'll be 5. Let's do this. Okay, erase that. That'll be 5. This will be 10. I just don't want so many numbers up here. Okay. So if I sold 0 drawings, remember my money I've made is minus 30. If I sell 1 drawing, I'm only at minus 28. I want to put a very tiny 28 dot in there. Okay. Then we said, well, what about if I sell 5 drawings? 5 drawings only got me up to here. 5 drawings only got me to there. And then we said, well, what if I sold 30 drawings? So my X was 30. And then finally, my Y was $30 up here. So now we can kind of see where our line is going. We can draw our line in there, and you're going to use a ruler to make a nice straight line here. I'll try and get it in there nice and straight. My line's just slightly off here. I want to slide it down just a little bit. Yours with your ruler will be easier to line up than mine. Let's get it right in there where it's lined up on all my dots. There we go. Okay. So now we can see just exactly where my line is going. Okay, so we want to know, what would his income be if he sells 15 drawings? Well, what would his income be? We can put it in as our input in order to get out our output. So we're making a prediction for 15 drawings, right? 2 times 15 would be 30 minus 30. He would make $0. He'd just barely be breaking even, right? So now we can see how we can use these equations, these functions, in order to make predictions about what our number of drawings should be. Okay, so I hope that helped. Oh, I never had you fill in points from over here. If you want to, if you work better from coordinate points, fill these in, right? With your data table. We chose a 1, and that was a negative 28. We chose a 5 and a negative 20, and we chose a 30 and a 30. I don't want to skip over things for you guys, but that's where I just plotted my points straight from this data up here. I plotted my points straight from this data up here, and I didn't turn them into ordered pairs. If it helps you to plot your points by turning them into ordered pairs, please do that. I think it asks you to do that on your assignment today in a couple of places. Okay, I don't want to skip out on that. So there is writing, graphing, getting data, all from linear equations. And our next assignment, we will be kind of doing the same thing, but we are going to level up just a tiny bit. So making predictions is very important, and using functions to make predictions is how we do things in the real world. That's the kind of way that we do things, like we predict the weather. We come up with some data. We see what the pattern of data looks like on a graph, and then we come up with an equation from that in order to make a prediction about something that follows a pattern. Okay, well, good luck on your assignment today, and if you have any questions or need some clarification, remember you can always email me or Mrs. Zeider, or come in for some help after school, or join us for our Google Meet on Wednesdays at 3 p.m. Okay, thanks guys.